Let's take a look at an example problem for Module 7.2 for ME 270 Structural Dynamics course. So in this problem here, we want to consider a fourth order system represented by a single fourth order differential equation with input x and output z. So we're given this equation here, our z, 4 dots, a1z triple dot, a2z double dot, a3z dot, plus a4z is equal to b naught x. We also have now our q dot is ax plus our bu, and our y is equal to cx plus du. Let's note down here, for this problem, a state space representation is straightforward to find, but in many cases, in the case where there are derivatives on the right side of the differential equation, this problem can be much more difficult to solve. So this is just a simple case that we'll go through to understand the format and how to approach the solution to this. Some of these more difficult cases are explained in discussions of the transformations between systems representations. So now that we've read through the problem, understand what they've given and what they're asking us to solve, we want to create our setup page. So again, this is just a simple example that we're working on here. Fourth order system represented by a single fourth order differential equation with inputs x and outputs z. So we're given three different things basically in this: a fourth order system, single fourth order differential equation, inputs out x, outputs z. So we write this down just so we understand what it is within the problem. And again, because this is a simple problem, it's not super crucial to keep rewriting this like I have, but as they get more complicated, if we're in this habit of really clearly understanding what everything is, it's going to make life a lot easier for those more difficult problems. So I rewrite this out over here as we saw given the problem statement. I have my z4 dots, a1 z triple dot, a2 z double dot, a3 z dot, a4 z is equal to b naught x. And again, I have this relationship down here for my q dot, and my y is relating back to a, b, c, and d. So now that we have our setup page that we can reference back to, take a look at all of our given equations, what they're asking us to solve for, and our problem statement, what we want to do next is begin our actual solution. So here on page 1 of our solution, we see I rewrite out that same equation I had on the previous slide, but now I'm kind of going through and grouping things. So I have 4 new variables I'm going to define here, q1 through q4. So q1, which I have in blue here, is my z's, q2, which is q1 dot or z dot, q3, which is q2 dot or z double dot, and q4, which is q3 dot or z triple dot. So I go through and find those all up here in my given equation here, so I can replace all of those down here in this next equation there. So I have, okay, there's my z triple dot, there's my z triple dot right there, there's my z double dot there, z dot, z dot, z, and z. So I can replace those all now with my q1, 2, 3, and 4. And that's what I do down here in this equation here. I replace my z triple dot with my q4, replace my z double dot with my q3, I replace my z dot with my q2, and I replace my z with my q1 there. And I also note that my q dot 4 is going to be my z 4 dot right there. So from this here, the next step is to resimplify this down, draw it out again here. So I rewrite that equation in terms of a's and q's. So I have this relationship here, z 4 dot is equal to q 4 dot, again from this relationship right here, which is equal to negative a4 q1 minus a3 q2 minus a2 q3 minus a1 q4 plus my b naught x. I put this on this side of the equation here as compared to up top where it's on the right hand side of the equal sign. So I rewrite that general equation that I just solved for right there and rearranged right here. So the next step, we can rewrite the fourth order differential equation as 4 first order equations. So now we're dealing with just first order differential equations. It's a lot easier for us to solve. So we do this here. We say, okay, my q1 dot again is my z dot, my q2 dot is my z double dot, my q3 dot is my z triple dot, and my q4 is now represented by this relationship here that we just solved for from above, from this relationship up here. So I can use this information and I can start plugging this into a matrix form. So this is compactly written in the space form by the following here. So we recall our q dot, I'm given in the problem statement here, is our aq plus bu. So I write that down here, okay. So there is our aq times bu is equal to our q dot. So this is our q dot vector right here to correspond with this. Here is our A matrix right here to correspond with our A. our Q matrix right here to correspond with our Q, plus our B matrix right here, which is right there, correspond with our U or our X right there. And on the other relationship we have here, we have that Y is equal to CQ plus our DU there. So we can rewrite that. There's our C times our Q right there. So I'm going to rewrite all these out a little bit bigger, a little bit clearer, so we can clearly understand what all of our A, B, C, and D are for this equation here. So we have our A matrix here. We have 0, 1, 0, 0. 0, 0, 1, 0, 0, 0, 0, 1, and then our negative A4, negative A3, negative A2, and negative A1 in matrix form. So we have a 4 by 4 matrix there. Our B is this vector here, 0, 0, 0, B naught. Our C is given by this over here, 1, 0, 0, 0, and our D is simply 0 here. So recall that our input is X, and our output is Z, or our X is also U, the way we've written out this here, so those are interchangeable for us. So now we have our A, B, C, and D.